What is artificial intelligence and machine learning? In recent years, artificial intelligence, AI, and machine learning, ML, have become buzzwords in the technology industry and beyond. From self-driving cars to voice assistants, these cutting-edge technologies have transformed the way we live, work, and interact with the world. This comprehensive text aims to delve into the fascinating world of AI and ML, exploring their definitions, applications, underlying concepts, and potential implications for the future. Understanding artificial intelligence. What is artificial intelligence? Artificial intelligence, often referred to as AI, is the simulation of human intelligence in machines, enabling them to perform tasks that would typically require human intelligence. These tasks include visual perception, speech recognition, decision-making, problem-solving, and natural language processing. AI encompasses a wide range of techniques and approaches, including machine learning, natural language processing, computer vision, robotics, and expert systems. The history of artificial intelligence. The history of AI dates back to the 1950s when researchers began exploring the possibility of creating machines capable of intelligent behavior. The field witnessed significant breakthroughs and setbacks, with milestones like the development of the General Problem Solver, GPS, and the birth of expert systems. However, due to limitations in computing power and data availability, progress was slow until the late 1990s when advancements in hardware and algorithms sparked a resurgence in AI research. Machine learning, the engine of AI. Understanding machine learning. Machine learning, ML, is a subset of AI that focuses on the development of algorithms and statistical models that enable computers to learn from and make predictions or decisions based on data. ML algorithms are designed to automatically identify patterns, learn from them, and make informed decisions or predictions without being explicitly programmed. Types of machine learning. There are several types of ML algorithms, each suited to different types of problems. These include supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, and deep learning. Each type has its unique characteristics and applications, allowing machines to learn from data in various ways. Key concepts in machine learning. Training data. ML algorithms require large amounts of training data to learn from. This data is usually labeled, meaning it contains input examples paired with corresponding desired outputs or outcomes. By analyzing this labeled data, ML models can learn to recognize patterns and generalize from them. Feature extraction. Feature extraction involves identifying relevant characteristics or features within the training data that help the ML model understand the underlying patterns. These features serve as input variables for the model to make predictions or decisions. Model selection. ML encompasses various types of models, each suited to different types of problems. These models range from simple linear regression to complex deep neural networks. Choosing the appropriate model depends on the nature of the data and the desired outcome. Training and evaluation. During the training phase, ML models are exposed to the labeled training data, which helps them adjust their internal parameters and optimize their performance. Evaluation involves assessing the model's accuracy and generalization ability by using separate datasets. Prediction and inference. Once trained, ML models can make predictions or decisions on new, unseen data. They apply the knowledge gained during training to infer outcomes, classify objects, or generate insights. Advancements and challenges in AI and ML. Recent advancements in AI and ML. AI and ML have witnessed remarkable advancements in recent years. Deep learning, a subset of ML inspired by the structure and function of the human brain, has revolutionized the field. It has enabled breakthroughs in areas such as image recognition, natural language processing, and speech synthesis. Additionally, advancements in hardware, such as graphics processing units, GPUs, and specialized AI chips, have accelerated AI and ML computations. Applications of AI and ML. AI and ML have found applications in a wide range of industries and domains. Here are a few notable examples. Healthcare. AI and ML are revolutionizing healthcare by enabling more accurate diagnostics, personalized treatments, and efficient drug discovery. ML algorithms can analyze medical imaging data, genetic information, and patient records to assist in early disease detection and recommend tailored treatment plans. Finance. AI and ML are transforming the financial sector, improving fraud detection, risk assessment, and trading strategies. ML algorithms analyze vast amounts of financial data to identify patterns and anomalies, helping financial institutions make informed decisions and mitigate risks. Transportation. Autonomous vehicles are a prominent application of AI and ML in the transportation sector. ML models process sensor data from cameras, radar, and lidar systems to perceive the environment, navigate roads, and make real-time driving decisions. Customer experience. AI-powered chatbots and virtual assistants enhance customer service by providing personalized assistance and addressing queries in real time. These systems use ML algorithms to understand natural language, interpret user intent, and deliver relevant responses. Ethical considerations and implications. As AI and ML continue to progress, ethical considerations and potential implications arise. Concerns include algorithmic bias, privacy concerns, job displacement, and the impact on social dynamics. It is crucial to develop frameworks and regulations that ensure responsible and ethical AI development and deployment. Future perspectives and impact. The future of AI and ML is promising, with significant potential impact on various aspects of society. Advancements in AI-driven healthcare could lead to improved diagnostics and personalized treatments. Autonomous vehicles could transform transportation, making it safer and more efficient. However, there are also concerns about the societal and economic implications of widespread AI adoption and the need for continued human oversight. Conclusion. Artificial intelligence and machine learning are reshaping the world as we know it. From the way we interact with technology to how industries operate, their impact is profound. As we embrace the possibilities of AI and ML, it is essential to strike a balance between progress and ethical considerations, ensuring that these technologies benefit humanity as a whole. By understanding the concepts, applications, and challenges of AI and ML, we can harness their potential to create a better future.